this video for Computer Science 9618 A-Level, we're going to be taking a look at a full paper 4 walkthrough. This is the most recent exam that was given back in October, November of 2024, so just a few months ago. Today we'll be taking a look at Variant 1, the grade thresholds for paper 4, as well as some tips that you can pick up from practicing this exam. So let's go ahead and let's take a look at part 1. So one source file is used to answer question 1. The file is called data.txt. When you get your paper 4 exam, you should be getting 2 electronic files. One file should be a TXT file that's included in almost every paper 4 exam. You'll also be getting an evidence document, and this evidence document is where you're going to copy and where you're going to paste your code. The data.txt needs to be put onto the computer and inside your program file so you can access it from within your program. A program sorts string data using different sorting methods. The text file data.txt stores string data items. Each data item is on a new line in the text file. So we know that each item that we need to record from that file or to take in from that file is going to be on its own line. That makes it a lot easier to work with. It says the function read data. I know it's a function. This tells me that this is going to return a value. It says it has a local array of strings that can store 45 items. That local array is very important. I need to make sure that I declare that inside the function. That's what it means by local. So it's not going to be a global array. It's going to be a local array, and that's going to be done inside the function read data. It says it reads each line of data, stores it in the array, and then it returns the array. But where is it returning the array to? Well, it's going to return an array to the procedure or function that calls read data. That's where we're going to find it. It wants us to write program code for the function read data. So we're going to write a function as well as learn how to return an array. Let's swing over to vb.net and let's code this out. Because this question deals with a text file, we need to import the system.io. So imports system.io. This will allow me to create a variable as a stream reader, which will allow us to read the file. So what we're going to do is we're going to put that in sub back. We're going to do function, and they wanted us to call it read data. It doesn't accept any parameters, but it does return a string array. Now, how do I let VB know I'm returning an array of strings? Because if I put as string, that tells VB I'm returning a single item, but it wants me to return an array of strings. Here's how you return an array. Just add a set of parentheses after your data type, and this lets VB.net know you're going to be turning an array of strings. Now we need a couple variables. The first one is file handle, and that's going to be a stream reader. The reason I can do a stream reader is because I imported my system.io, so I misspelled it. So now it'll let me do stream reader. If you don't import the system.io, you're not going to be able to import or declare a variable as a stream reader. You're not going to be able to read that file. The next thing we need is colors as string. How do I know it's colors? I open the file. When you get your text file from your examiner, make sure you open it. Make sure it has the data in it. If you have a blank file, that's a problem. You need to let your examiner know. Do not alter the contents of the file. If you do, ask your examiner for a fresh copy because you're going to need the data that's inside that file. I looked inside the file. I saw that was colors. It doesn't tell us what the data is when we read question 1, so feel free to open that file. That is allowed. Now it tells us there are 45 items that we need to record. You have two options. You can do 45, skip over index 0 and start at index 1, or you can do 44 and include index 0. When I count from index 0 to index 44, that is 45 items. And the problem told us there were 45 items that we need to record inside the file. Now, anytime you're wanting to read a file, you want to put it in a try catch statement. This try catch statement is an error handling. If the file doesn't exist, instead of your program crashing, we are going to output a message that says the file cannot be found. So we're going to do console.writeLine. We're just going to handle the exception first. File not found. And then we're going to try to open that file. We do that by file handle. What is file handle? That is my stream reader. And that's going to be a new system.io.stream reader. And then inside this parentheses, I put the name of the file, data.txt. That's what I'm going to try to open. This right here will open the file. Now, once I open that file, I need to start storing all the items inside my color array. So I'm going to do for I equals 0 to 44. Now, if you're admitting index 0, and you want to start at index 1, you're going to need to make sure this is 45, and your I loop would go from index 1 to index 45. And that's what I stands for. So I'm going to do colors, I, equals, and then I'm going to do file handle, which is my stream reader. And what am I doing? I'm reading each line. That allows me to have this .readLine method that I can use for my file handle. This will iterate through the entire file. Now, as soon as I'm done with the file, we want to make sure we close that file. So we're going to do file handle .close, and that will close this data.txt. We already have our exception. All we need to do now at the end of this function is return this string array. What is that string array? That's going to be colors. So we simply type in return colors, and that will return the array to whatever method calls this function. Let's take a look at the next part of the question. So we've picked up 6 points on our exam so far. Taking a look at the next part, part B, the function format array takes an array of strings as a parameter so that we return that array. So now we're going to send that array to format array. It concatenates the contents of the array into one string with a space between each array element. I find that very bizarre that we're going to take 45 items, 45 colors, and put it into one string. But if that's what they want, that's what we'll code for them. The function returns the concatenated string. So we're going to return this very long string. Write program code for format array. Then part 2 says the main program. What do they mean by main program? That is sub main. We're going to write some code there too. It says calls read data and stores the returned array. So we're going to need to create an array inside sub main that's going to hold all those colors. Because remember, inside read data, we're returning 45 items that's stored in that string array. So we're going to need another array inside our sub main to hold that. Then it calls format array with the returned array and outputs the returned string. They want us to test our program and take a screenshot of the output. Now, before you call read data, make sure that text file is closed. If you have it open, it's not going to be able to be read from because it's going to be in use. So make sure you close that text file before you run your program. Let's swing over to VB.net and let's code this out. Okay, so we're going to write the format array. Now, if you're a type of person you don't want to see all this code, you can simply hit this down arrow and it'll collapse everything. And if you need to bring it back, just hit that arrow again. We'll go ahead and collapse it just so we can see how it works. Okay, so we're going to do that function, and it's called format array. Now, it does accept an array as a parameter. So we're going to do by ref. Then we're going to do, let's see here, we'll do colors. We'll just do colors as a string. And what does it return? It returns a single string, not an array of strings, just one huge concatenated string of all the colors. So what we're going to do is we're going to do return string as string. And what we're going to do is we're going to build onto the string every single color from that array. And we're going to make sure we're going to add a space in between each one. So we're going to do for I equals 0 to 44 because colors is going to have index 0 to 44. So we need to make sure we use 0 to 44. Our return string, what does our return string equal? Well, we're going to need to do our return string plus equals because we need to build onto the return string. If I just do return string equals, all it's going to do is it's going to take the last color, whatever's in index 44, and put it into return string. I don't want to do that. I want to build onto my existing string. What does plus equals do? It's the same thing as writing return string equals plus return string plus, and then the colors array. So this right here that I have will it'll do the return string and it will add on the colors I. It'll actually be and colors I. Now don't forget, we also need to put in a space. So we're going to do that. But I don't like doing this return string and colors. So what I'm going to do here is I'm just going to do plus equals. So when I do plus equals, it's going to combine colors, whatever the index is, a space, and it's going to tack that onto return string. Then all I need to do is I need to return that return string back to submain, and it's going to take all the colors inside the colors array. It's going to put it into one single string, and then it's going to return it. Now the next thing it did, it said the main program calls it. Now we need to create an array because this function that we have that returns this string array, we need an array to hold that. So all I need to do is I'm going to do dim all colors 44. I'm going to do that as a string. That's going to hold it. And then all I need to do is I need to populate all colors. And I do that by calling our read data. When I call read data, because it's returning a string, I don't need to do a for loop looking for each item one at a time. I can populate this entire array because this function is returning an array. The next thing I need to do is I need to print out what is returned by our format array. So console.writeLine, because we got to take a screenshot of our code. So that's why we're doing the console.writeLine. What am I calling? I'm calling format array. And what am I passing down to it? I'm passing down all the colors. So let's go ahead, let's save, let's run our code and see all the colors printed out as a single string. And here's our program, and we can see we have all the different colors, all of them right here inside our program. So let's go ahead and take a look at the next part of the question. The function compare strings takes two strings as parameters. So we're going to use the first parameter we're going to call string 1. The second one we're going to call string 2 or word 1, word 2. We'll see whatever we program when we get there. But it takes two strings as parameters. Compares each string one character at a time. That tells me right there I can use the mid function and iterate through each character of the string, isolating each character and comparing one character from the first word to one character from the second word, because we're trying to identify which string comes first alphabetically. So we're just seeing which one comes first. If the first two characters are the same, the second character of each string is compared. This continues until the two characters are different. The function returns 1 if the first parameter comes before the second alphabetically, returns 2 if the second parameter comes before the first alphabetically. Now this is important. You'll notice 1 and 2 are not inside quotes. That means it's not going to return a string, it's going to return an integer. So it wants us to write program code for the function compare strings. Assume that all strings are in lowercase. Why is that important? Well, because it's not actually comparing the letters, it's comparing the ASCII code value. For example, the lowercase letters start with a lowercase a with the value of 97. If I'm comparing apple and banana, I'm comparing A to B. But what the computer is doing is it's comparing the ASCII code value of the lowercase a, which is 97, to the ASCII code value of the lowercase b, which is 98. Because 97 comes before 98, the computer will determine that apple is less than banana. So that's how it works when you're using a greater than, less than sign, and the same thing's going to work here. You do not need to convert it to its ASCII code value. You're just going to isolate each letter and you're going to see which one is greater than the other. The one that is actually less than, you're going to return. The one that is greater, you're not going to return. And it tells us that right here, returns 1 or 2. Assume that a difference between two strings will always be identified before the end of one string is reached. Because that happens, we can use a for loop here and make it really easy to do. Do not use an inbuilt string comparison function. They want us to use string manipulation here. The strings must be compared one character at a time. They're letting us know that again, and that just screams using the mid function. Let's swing over to VB and let's code this out. Function compare strings, make that a lowercase o, and then it has two parameters. So we're going to do by val word 1 as string. We're going to do another by val word 2 as string, and then we look at the return data type, and that's going to be an integer because it's going to return either a 1 or a 2. Now I'm going to use a for loop, and I'm going to do for I equals 1. Why am I starting at 1? Well, I'm going to use mid, and when I use mid, it starts at index 1. If you're going to use substring, because maybe you like substring, you like to use that more than mid, that is another valid option. If you're going to use substring, you need to start at index 0 and you need to go to word1 dot length minus 1. Because I'm starting at mid, I need to go to word1 dot length. How do I know I need to go to word1 dot length and not word2 dot length? Well, word1 dot length or word2 dot length will work here. In the directions, it told us that it will determine if word 1 comes before word 2 alphabetically, or that word 2 becomes before word 1 alphabetically, based on before it reaches the end of the string. So because it's going to happen before it reaches either end of word 1 or word 2, we're able to do that. So all we're going to do is we're going to compare to see if the first word, word 1, is less than word 2, and we're talking about alphabetically. So I'm going to do if mid. I'm going to type in the string I'm working with, word 1. Starting at position I, character 1, I want 1 character. That's going to isolate each individual letter from this string, 1 letter at a time. I'm going to see if it's less than the character from word 2. So word 2, start at position I want 1 character. If that happens, then I know word 1 comes first. I return 1. Then I need to check to see if word 2 comes first alphabetically. So we're going to do else if, and we're going to do mid, word 1, I, 1. This time we're going to see if it's greater than word 2, I, 1. If it is, then what we need to do is we need to return 2. These return statements will allow us to exit the function. Now you may be saying, why don't we just do an else statement? If mid word 1, I, 1 is less than the first letter of the word 2, then if that's not true, obviously we're going to return 2. But we can't just do else return 2, because what if the first letter or the second letter, as long as we go through, if they're the same letter, we don't want to return word 2. So that's why we can't do an else statement. But that wraps up compare strings, because we're either going to return 1 or 2, and it will happen before we get to the end of either word 1 or word 2. Let's take a look at the next part of the question. For part D, the function bubble takes an array of strings as a parameter and sorts the data into ascending alphabetical order using a bubble sort. The bubble sort uses compare strings to compare each string. So we're going to take a look at that first word, and we're going to see if we need to swap places with the next word. If we do, we're going to go ahead and do that swap, and it's going to compare it all the way to the end of all the words inside the array. Now, it's very important when we're doing a bubble sort that once it compares itself all the way to the end, that we don't make that comparison again using the next word all the way to the end. When you make that final comparison at the very end, it doesn't get compared again, and you'll see that when we do our code. So let's swing over to VB.net, let's code out a bubble sort, and then talk about how it works. Before we write our function bubble, you'll notice this green line, and that's because VB doesn't know if this function will always return a value. It's a warning to say, hey, you know what? Your function may not actually return something. You may be missing a return statement. We know that at some point when we're comparing the strings, it's going to return a 1 or a 2. So you can simply ignore that green line. All right, let's write our function bubble. It takes an array as a parameter. So we're going to do colors, put my parentheses to let it know it's accepting an array. It's going to be a string, and then it's going to return a sorted array. So I put those parentheses at the end, just like we talked about earlier. Now, when you're writing your bubble sort, there are multiple ways to do it. I don't like using nested for loops. Some people do. If you like that, great. I don't like doing that. I like to make it as neat, easy, and clean to read as possible. That way, if my code's not working, I can fix it. So the first thing we're going to do is we're going to do value as integer. That's going to hold either the 1 or the 2 that's being returned by compare strings. The next thing I need is I need a temp variable. This is in case I need to swap places for word 1 and word 2. If word 2 needs to swap places with word 1, I need to back up the data for word 1 inside a temp variable. This is because I'm going to move word 2 to where word 1 is. If I don't back up the data, it's going to overwrite the data for word 1. By backing it up in a temp variable, I can keep it. Once I move word 2 to where word 1 is, I can take what's inside my temp variable and put it into the place where word 2 was, since I've already overwritten and moved word 2. The next thing I need is I need max index. This is going to be an integer. This max index is going to hold how far I need to go in my for loop. When we do the first comparison, it's going to find the largest word, because we're going to start at the beginning of the array, and it's going to bubble all the way to the top or to the end of the array. That's how bubble sorts work. Once I have already found the largest word and it has bubbled to the end of the array, I don't need to make that comparison again. So we're actually going to decrement max index by 1 as we go through. The last one I need is no more swaps as Boolean. We're going to keep going through and comparing, starting back at the beginning of the array every single time until no swaps have taken place. Once no more swaps have taken place, we know everything is in order and we can exit that loop. So let's go ahead and get started. So I'm going to do until no more swaps equals true. And the first thing I'm going to do is I'm going to set no more swaps equal to true, because it's possible, although it's not possible in this scenario, but if you're writing a standard bubble sort, it's possible that you have an array that is already in order and that no swaps need to take place. That's why we have that. Now, we're going to do for I equals 0 to max index. Now, max index isn't going to stay at 44. So we're going to do max index equals 44. Remember, there are 45 colors because we're starting at index 0. If I go 0 to 44, that will hit every single color, all 45 of them. And we're going to decrement that by 1 at the end, because remember, the largest word is going to bubble to the top. Because it's bubbled to the top, I don't need to make any comparisons with that word, or after it runs multiple times, those words again. So the first thing I'm going to need to do is I need to check, do we need to swap places? Well, the first thing I need to do is load up value by calling compare strings, and I need to pass word 1 and word 2. Well, that's going to be in my array. Colors I is word 1, and then colors I plus 1, the next index will be color the next color or word 2 that we're comparing to word 1. If we need to swap places, if value equals 2, then we need to swap places. So that means temp. What are we going to put in temp? Colors I. We want to back up that data because what we're going to do what are we going to put in colors I? Colors I plus 1. We are going to overwrite colors I. This is why I need to back it up. And then what am I going to put where word 2 was? What am I putting inside colors I plus 1? I'm putting in temp, the backup of word 1. Now, no more swaps equals false because I just made a swap, which means when I get to the end of my max index, I'm going to need to start again. So we're going to loop back around. No more swaps is false. We're going to reset it to true, and we're going to make all the comparisons. But we're not going to go all the way to the end. We don't need to make the comparison all the way to the end because remember, the largest word alphabetically is going to bubble all the way to the top. We don't need to make a comparison with that word again. When it runs the second time, the second largest word will bubble all the way to index 43 because it's already been compared to index 44. So all we're going to do is we're going to do max index minus equals 1. Then what we're going to do outside this loop, when there's no more swaps, we're done with our bubble sort, and we're going to return colors, that array, because now it has been sorted. That is how you write an efficient bubble sort. Let's take a look at the next part of the question. So they want us to write program code to amend the main program. What does that mean? That means we want to update sub main. We're going to call bubble with the unsorted array as a parameter. Remember, the whole point of bubble is to sort all those colors and put it into alphabetical order. Then we're going to call format array with the sorted array, output the return string. Remember, format array is going to take the array and it's going to put it all into one string and it will output them in alphabetical order. So we're going to test our program and make sure the output is correct. Let's swing over to vb.net and make those calls. All right, we're back in submain. I need all colors sorted. I need another array here. Make that 44 as string. Then what I'm going to do is I'm going to leave the original lines in there. Then I'm going to do console.writeLine. After sorting. Let me put that in after we actually sort it. We want our examiner to know that we know what we're doing. And we're going to do all colors sorted. We're going to call our bubble sort, and we're going to pass down all 44 colors. And now that I think about it, let me go back down to this bubble sort here. Yeah, this is going to crash. Okay, we need to do max index minus 1. Okay, let me explain why we need to do this. Otherwise, it's going to crash. Our max index is 44. When we reach max index of 44, if we don't put the minus 1 in there, we're going to reach 44. It's going to compare max index 44 with index 45 because 44 plus 1 is 45. There is no index 45. Our program is going to crash. Now you might be saying, well, how in the world are we supposed to compare it with the last number in the index? Because max index minus 1, the first time this for loop runs, it's only going to get to 43. That's fine because we're going to load word 1 or colors I. That's going to be index 43, and we're going to be comparing it with index 44, which is 43 plus 1. If we don't have this for I equals 0 to max index minus 1, our program is going to crash. So I'm glad we saw that before we ran it. If we ran it and it crashed, no big deal, we'd go down and fix it. So make sure you fix it. Then all we're going to do now is we're going to do console.writeLine, and we're going to call format array again, all colors sorted. We want to make sure you spell your function correctly, format array, perfect. And then I'm going to put in a console.readline to pause my program. All right, let's run this thing, and we should see all the colors alphabetical. All right, so here's all our colors that are not in alphabetical order, and here is all our colors, and they appear to be in alphabetical order. Going through, now here you'll see mage. Understand that if you expand your window, it'll be the right color. Do you need to expand your window? No, you don't. They do understand that it will word wrap. So when you see MAGEN, the TA is part of that. So you can leave that there. If you don't want to, because you don't like the way it looks, then simply stretch it out so you can see all those colors. We'll get turquoise a little more. See, if we do that, so I don't want to go off the screen here. Oh, there we go, magenta and scarlet. That lines up perfectly. So we can see they are all in alphabetical order after being sorted. So that wraps it up for, the last thing we need to do is count, make sure there's 45 colors here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. All 45 colors are there. I'd like to prove to you, even though I can't spell, that I can count. That wraps it up for question 1. Let's go ahead and take a look at question 2. A computer program is designed to simulate horses doing show jumping. Now, in show jumping, horses jump over obstacles called fences. A horse successfully jumps a fence if it does not knock the fence down. The program is written using object-oriented programming. So we can see the class name is horse, we have the attributes, and we have the methods that are being written. Let's take a look at the first part of the question about object-oriented programming so we know what we need to do. Write program code to declare the class horse and its constructor. Do not declare the other methods. So what are we doing when we declare this class horse? Well, we need to create the class horse. We need to create the attribute name, declare it as a string, max fence height, which is going to be an integer, and percentage success, which is also an integer. And here you can see they're giving us descriptions about what's being done. Now, when you're declaring a class, you need to know what that means. That means we must create these attributes in the class, and we also need to create our constructor. Those are the only things you need to do when you're creating your class. Now, when you're creating the constructor, it is not called public sub constructor. Each language has its own way of creating the constructor. That's why it says use your programming language's appropriate constructor. In VB.NET, it's public sub new. Also, when you're looking at the constructor, you need to read the description to see if it accepts any parameters. Because in order to get points for that constructor, if it takes parameters, you need to have that. So let's take a look. Initializes name, max fence height, and percentage success, all three of these attributes, to its parameter values. So we're going to accept a parameter value, take that value, and assign it to name, max fence height, and percentage success. Let's swing over to VB.NET and take a look at how that's done. So when you're over here in VB.NET, we're going to create that public class. They tell us what they wanted it to be called. They want it to be called horse. That right there gives me a point. Now, when you're declaring these attributes, the name, the max fence height, the percentage success, you need to make sure all the attributes are always private. Now, sometimes on the exam, they'll remind you that they must be private. Sometimes on the exam, they're not going to remind you. Either way, whether they remind you or not, you need to remember that all attributes must be private. So all we do is private name as string. We do private max fence height as integer, and we do private, and then we do percentage success. So exactly what they tell us what they want it to be called. We just take it and we convert it to code. That right there, because they're private, We use the names and we declare the correct data types for each of these, which again, they give us, we're able to pick up a point. Now, the third point comes from our constructor, which is public sub new. It will always be public sub new. Now, this right here does not get you a point. Yeah, it does say it takes 3 parameter values. So we need to make sure we take 3 parameter values and then assign them to these 3 attributes that we have right there. If we do that successfully, we'll pick up our third point, and we should be able to do it successfully. So we're going to do by val in as string, that's for my name. By val, I'll do mfh for max fence height, that is an integer. And then one more by val, and that's going to be ps for percentage success, that's going to be an integer. All I got to do now is take these parameter values and assign them to the attributes. That means name equals in. I'm taking the parameter in, I'm assigning it to name. For max fence height, I'm taking mfh, whatever that parameter value is going to be, and I'm putting it inside max fence height. And the last one, percentage success, I'm taking PS and putting it in there. Once you have your constructor with the 3 parameter values and you assign them to the attributes, you're going to pick up your third point for part A. Let's take a look at the next part of the question, see what they want us to do. The get methods, get name and get max fence height, each return the relevant attribute. So here in this question, we have get methods. What about set methods? Why does this problem not have set methods? Because the values that we're setting initially are being done inside the constructor. If they weren't being done inside the constructor, we would have separate set methods. So how are you supposed to know which one you're supposed to use? They will always tell you. Now these get methods, get name is going to return the name of the horse. Get max fence height is going to return the maximum height the horse can jump. We are not doing anything with success just yet. Now remember, each attribute should have its own get method. That's why we have get name and get max fence height. What about get percentage success? That's going to be done somewhere inside the success method. But let's swing over to VB.net and program out these get methods. Make sure you're inside your class. This is where the get methods go. They are part of the class horse. Also, they need to be functions because subs do not return a value while functions do. So we're going to do public function, get name. Now, get methods do not take a parameter. The return data type of the name is a string because name is a string. I return the name, and it is that simple. I'm going to write another function called get max fence height. No parameters, but it does return an integer data type, and you want to spell integer correctly. And then we simply return max fence height, and just like that, we're done with our get methods, and we picked up another 3 points on our paper 4 exam. Let's take a look at the next part of the question. The array horses stores objects of type horse. The program has 2 horses. The horse named Beauty can jump a maximum height of 150 centimeters and has a success percentage rate of 72%. The horse named Jet can jump a maximum height of 160 centimeters and has a success percentage rate of 65%. They want us to write program code to declare the array horses local to the main program, which means we're going to do that inside submain with space for 2 horse objects and then store 2 horses described in the array right back up here. And then they want us to output the name of both horse objects from the array. So we're going to use that get name method. Let's swing over to VB.net, talk about how to create an array of objects because we have to do that here. And then how do we access the get method from different objects inside an array. Let's swing over to VB.net and let's do that now. So when it says make that array local to the main program, that means submain. So we're going to do dim. We're going to do horses. You can't do horse. That's the name of your class. Horses. Now I'm going to use a max index of 1. If you'd like to use a max index of 2 and skip over index 0, you can feel free to do that. Each way will be fine. And then I'm going to do this as. Now, when you're creating a single object, you always do new and then horse. That's not going to work here because when you do new, it doesn't know which value you're talking about or which index you're talking about. Are you talking about index 0? Are you talking about index 1? So what you do is you just put horse. That will get rid of your red line. Now what you're going to do is we're going to access each index separately, and we're going to create a new horse and instantiate an object, which is a fancy way of saying we're creating an object. So horse is in index 0. It's going to be a new horse. Now, you'll notice we have a red line here. Why? Because our constructor, the public sub new, takes 3 parameters. The first one is the name, Beauty. We look at Beauty's information. She has a max fence height jump of 150 with a 72% success rate. Now, that red line is gone. Then I'm going to do horses, index 1 equals new horse. That horse's name was Jet. He has a max fence height of 160 and he has a success rate of 65%. Now it wants us to output the names of each horse. So you have 2 options here because there's only 2 objects. You can use 2 console.writeLine, so you could do this. So just console.writeLine, horses 0.getName. And you want to put that close parentheses, reference the index. You can do that. You can do horses 0.getName, or you can use a for loop. I'm going to show you how to use a for loop. That way, if you ever, in the future, if you ever have like 3 or 4 or 5 objects, you can simply use a for loop to do it. Now, when we're creating the horses, we can't use a for loop because we have to give it these values. If the constructor didn't accept any values, we can instantiate an object of an array using a for loop. So I'm going to do for I equals 0 to 1. And what I can do here is I can use my for loop to output the names. Console.writeLine. Then I'm going to do horses I dot get name. And what that will do is it'll access index 0, index 1, get the name. When we run our program, it should output Beauty followed by Jet. And you can see here, it is output Beauty and Jet. That satisfies that part of the question. Let's take a look at the next part of the question. The class fence stores data about the fences. Each fence has a height in centimeters and a risk number. The risk is a whole number between 1 and 5 inclusive, so that includes 1 all the way up to 5. A risk of 1 means the fence is the easiest type to jump. A risk of 5 means the fence is the hardest type to jump. Write program code to declare the class fence, its constructor, and its get method. So we need to do the attributes of the fence class. We need to do the constructor, our public sub new. We can see it initializes height and risk to its parameter values. So it's going to take 2 parameters. And we have 2 get methods, get height and get risk. We know our get methods are going to be functions because functions return a value. Now, it doesn't mention anything about inheritance here. Now, inheritance could show up on the exam, but a fence is not part of a horse. So fence is not going to inherit the horse class. How do you know if you have to use inheritance? It will tell you if inheritance needs to be used. But for this question, there is no inheritance. We just create a separate class. So let's swing over to VB.net and let's program out this fence class. All right, when you're creating a separate class, make sure you go outside of your horse class. So make sure you're outside the in class here. Make sure you're in between submain. The classes can be in any order. It doesn't matter, but we're going to do the second one. Second, just so we can keep our code organized, public class fence. Now, all your attributes need to be private. The first one is height. The second one is risk. And risk is an integer, and height is an integer as well. We need to create that constructor, public sub new. It does take 2 parameters, and that is for height and risk. So I'm going to do h as integer. I'm going to do by val r as integer. Then I have my in sub, and then I'm going to do height in the right correct spot here. Height equals H, and then risk equals R. That takes care of the constructor. What I need to do now is I need to write those two get methods. So that's going to be public function, because functions return a value, get height, no parameters as integer, because height is an integer. That's what it's going to be returning. I return height. Then what I'm going to do is do the other get method, public function, and that is get risk as integer, and it's just going to return risk. Just like that, we've declared the fence class and picked up more points on our paper 4 exam. Let's go ahead and take a look at the next part of the question. The array course stores 4 fence objects. The user inputs the height and risk for each fence, and these are validated before each fence is created. So we need to make sure that height falls within the appropriate range, as well as risk. Because remember, risk needs to be between 1 and 5 inclusive. So we need to make sure that that is correct. So we're going to declare the local array course. So again, we're amending the main program, sub main. We're going to create an array called course that's going to hold 4 fences. We're going to take as input the data for 4 fences from the user. We're going to loop the input until both the height and risk are valid for each fence. We're going to create an instance of fence. What does that mean? We're going to create an object for the array for each of the 4 valid fences and store each instance in the array. So when they talk about creating an instance, they're talking about creating an object of that class they mentioned. And because we're creating an instance of the fence class, we're creating an object for the fence class, and it's going to be an array of objects, which we are calling course. Let's swing over to VB.net and do that now. All right, we're back over in VB.net. The first thing we need to do is we need to create that array that's going to hold the 4 fence objects, and they call that course. Now I'm going to do 3 here, and that's going to be of the fence class, so I'm going to dimensionalize that as fence. Now I also need 2 more variables because I'm going to be getting user input. The first one is for height. The next one is for risk. So I'm going to do those. And because those are not attributes, I'm going to use the keyword dim, not private. Because the height and risk, yes, those are attributes of the fence class. But when I create the fence objects and put them in the course array, I'm going to be sending the user input to the constructor. How do I do that? I need to record what they type in for height and what they type in for risk. I also need to validate it and make sure it's within the correct bounds. Now, we're going to use a for loop here. So we're going to do for I equals 0 to 3. That will allow me to create my 4 fence objects. So we're going to put some do loops in here, and after we validate both the height and the risk and make sure they're within the appropriate bounds, then we are going to create the object. That will happen inside the for loop. That way I don't have to have multiple lines doing the same thing. So the first question I'm going to ask is for them, console.writeLine, enter the height. So then what we're going to do is we're going to do height equals console.readLine. Now, I need to keep asking this question until the height is in the correct bounds. And when we look back at the description, the height must be greater than equal to 70, but at the same time, height needs to be less than or equal to 180. And that was in the description they gave us. Once that is met, it'll move on, it'll exit this loop and move on to the next one. And we need to loop until risk, and we'll get their prompt in a minute, risk is greater than or equal to 1. And risk at the same time must be less than or equal to 5. So we're going to do console.writeLine. We don't want to read the line first. Enter the risk value. Let's go back and put height value here. There we go. And then risk equals console.readLine. Once they have entered valid inputs for both the height And for the risk, we can create the object. So that's going to be course I. And what are we doing? We're creating a new fence object. And we have to pass both the height and the risk. So I put that here inside the parentheses. I'm passing down or passing up to the constructor, both height and risk. Just like that, we have finished that part of the question. We have an array, we've taken input, we validated the input, and we created 4 fence objects. Let's take a look at the next part of the question. The chance of a horse jumping a fence without knocking it down is calculated as follows. If the height of the fence is more than the maximum height a horse can jump, the success percentage is 20% of the horse's percentage success. So we would just take 20% of their percentage success, which we recorded as an integer earlier on. The risk does not affect this value. If the height of a fence is less than or equal to the maximum height a horse can jump, the risk gives a modifier value to multiply with the horse's percentage success. So if it has a risk of 5, we're going to multiply their percentage success by 0.6. Risk of 4, we multiply it by 0.7. 3, we multiply it by 0.8. 2, we multiply by 0.9. If it has a risk value of 1, we don't need to multiply the percentage success by 1 because it's just the value that it is. So you don't need to multiply it by 1, but you can if you want. The horse jet has a percentage success of 65, a max fence height of 160. A fence has a height of 140 and a risk of 3. The height of the fence is less than the horse's max fence height, therefore the risk is used. The risk of 3 gives the modifier 0.8, so we're going to take 0.8, we're going to multiply it by jet's percentage success of 65, that gives us the value of 52, so the chance of the horse successfully jumping this fence is 52%. So that's the example they give, that's the expected output for jet. The method success in the horse class takes the height and risk of a fence as parameters, calculates the percentage chance of success for that horse jumping the fence without knocking it down, returns a calculated percentage chance of success as a real number. So that tells us that the return data type is going to be a decimal. So the method success in the horse class takes the height and risk of a fence as parameters. You do not need to pass a fence object. Height and risk are the attributes of the fence class. We're going to accept those parameters as integers. Now we'll be using those get methods when we call success later on. Calculates the percentage chance of success for that horse jumping the fence without knocking it down. So we're going to use those values we just looked at. We're going to have some multiplying here based on these values on the previous page, and then returns the calculated percentage chance of success as a real number, which means it's going to be a decimal. Write program code for success. Let's swing over to VB.net and let's code out this success method. Okay, we're going to write this function success, but you have 2 classes. You have public class horse and public class fence. Which one does it go in? Well, the directions told us that it goes inside the horse class, so we want to make sure we're inside that horse class. And here I'm inside the horse class to write that function success. Now it takes 2 parameters. It takes height as an integer, and it takes risk as integer. And it returns a real number, which is the decimal data type. Now, height and risk, that's from the fence. You don't pass the object. When we call success, we're gonna use the get height function in the fence class. We're gonna use the get risk function inside the fence class, and we're gonna use that when we call success. Now, there's a couple things we need to check here. And if you're feeling overwhelmed by this question, don't. Just break it down nice and slow. Nothing that you can't handle. You're simply doing if statements, which you've done before. You're doing multiplication, which you've done before. And you're returning values from a function, which you've done before. Nothing you can't handle. So if you're feeling overwhelmed, don't. Just break it down nice and slow. Let's check that height. Let's check that height parameter. Let's see if it's greater than the max fence height of the horse that's calling this method. If it is, then what we're going to do is we're going to return that percentage success after we multiply it by 0.2, just like the directions told us. But how does it know which max fence height to use? How does it know which percentage success to use? We have two horses. We have Beauty and we have Jet. How does VB know which max fence height to use? If Beauty calls success, it will use Beauty's max fence height and it will use Beauty's percentage success. If Jet calls success, it's going to use Jet's max fence height and Jet's percentage success. So each method or each object that's created has its own max fence height and has its own percentage success. Because it has its own values, VB is going to use the values that are associated with the object that calls this method. So that's how it knows which one to use. Now there's another possibility, and that is max fence height is greater than height. If it is, we check that risk value. If risk equals 5, then what we're going to do is we're going to return that percentage success after, let me back it up here, after we multiply it by 0.6. Else if risk equals 4, then what we're going to do is we're going to return percentage success. Make sure we're in the right spot here. Percentage success times 0.7. And all I'm doing is looking right on that chart. If risk equals 3, then I'm going to return that percentage success times 0.8. Else if risk equals 2, then I can return the percentage success times 0.9. And then just to keep it in the same format, you can use else or else if here. I'm just going to do else if risk equals 1. That way it's easier for me to read my code. Return percentage success. That's it. I don't need to multiply it by 1. If I multiply it by 1, it's going to be the percentage success. Just like that, you have written out the success method successfully. So that's how you do it. Nothing that you can't handle. So let's go ahead and take a look at the next part of the question, because we're going to be calling this pretty shortly, I imagine. Write program code to amend the main program. So again, submain, calculate and output the chance of the first horse, that's going to be a Beauty, jumping each of the 4 fences without knocking each fence down. Calculate and output the chance of the second horse jumping each of the 4 fences without knocking each fence down. So we can use some for loops here. All outputs must have appropriate messages, including the name of the horse. So we're going to use that getName method. And the fence number. So an example output for one horse jumping 2 fences is the following. The horse Fox at fence 1 has a 68% chance of success. The horse Fox at fence 2 has a 72% chance of success. Now, because I used index 0, I'm going to need to add 1 to the fence number. So when I output, instead of fence 0, I need to make it say fence 1, fence 2. Do I have to do that? Probably, because their sample output starts at fence 1. Well, if I start at index 0, I simply need to add 1 onto the index number, and that will give me the appropriate fence number. Let's swing over to VB.net and let's code out this part. All right, so we're back in submain. I'm going to create another variable called chance as decimal, and that's for the value being returned by success. Do you have to have a variable called chance? No, you do not, but then your console.write line gets very, very long, and if it doesn't output the way you want, it can be a little trickier to correct that logic error. So we're going to do chance equals, and actually this is going to repeat, so we're going to do for I equals 0 to 1, because we can go through the array, and then we're going to have 4 fences for j equals 0 to 3. There we go. Okay, now the first thing I want to do is I need to get the horse I, which is going to be horse 0, and I need to calculate its chance of success for every single fence. So what I'm going to do here, so I'm going to do chance equals. Then I'm going to do my horses I, which is horses 0. I'm going to call that success method. Now, I need to pass the height and the risk. Here's how I do that. Course J, which is course 0, the very first fence, dot. I need to get the height. I'm going to pass that as my first parameter. The next parameter I'm going to pass is get risk. That will pass the height and the risk that we just wrote earlier. That will calculate the chance. Now, once I know the chance, I can output the horse's name, I can output the fence number, and their chance of success. So here we go, console.writeLine. It's going to be a big one. It's going to be a big one here. So I want to follow the same format. They did the horse. Put a space. And that's going to be horses I, because I'm on horses 0. Index 0, I mean. Get name. At fence. Now I need to get that fence number. So we don't want to do fence 0. So we're going to do J plus 1. That will output fence 1 for the first one, and then so on. At fence 1 has a, and let me scroll over here so we can see all of this at one time. It'll be a lot easier than trying to scroll multiple times. Has a, and then the next part they said a 68% chance. So has a chance and percent chance. We want to put those spaces in so it reads of, let me scroll over again, success. So still a long console.writeLine here. And we're forgetting something somewhere because we have a red line. Make sure we have all the ampersands we need. There we go. Okay, so it's because it was tacked on. There we go. So that will output the horse and all the its chance of jumping successfully over the 4 fences. Then I iterates to 1 after this inner loop finishes. Once J finishes, I iterate or increments to 1, and then it will do it for horse number 1, which is going to be Jet. So that's all we need to do for that. We called the get name method. We called the success method using the get height and get risk methods that we talked about. So let's swing over back to VB and let's take a look at the next part of the question. Write program code to amend the main program to calculate and output the average chance of success for each horse jumping over all 4 fences without knocking each fence down. Now the average is the total of values divided by the quantity of values. An example of output for one horse jumping all of the fences is the horse Fox has an average 70% chance of jumping over all 4 fences. Then output the name of the horse that has the highest average chance of success. You can assume that each average will be different. All outputs must have appropriate messages. So let's swing over to VB.net and let's go ahead and calculate the average chance of each horse jumping over all 4 fences and then output the horse that has the best chance of winning. All right, so we need to get the averages. So what we need is we're going to need total as decimal. We're also going to need average. Now, average, I'm going to go ahead and I'm going to make an array. And I'm going to have a max index of 1. Now, index 0 average is going to be tied to horses index 0. And then average index 1 is going to be tied to horses index 1. So average 0 will represent Beauty's average. Average index 1 will represent Jet's average. We're going to scroll down here to this for loop, and we need to increment total. We need to add up the total. So we're going to do total plus equals chance. That will give us the total. Then what we need to do is we need to calculate the average, and then we need to output it. So average I, we don't want to do average 0 because we'll overwrite Beauty's average. We want to use average I. We want to make sure we're outside this inner loop because after this inner loop runs an average index 0, we're going to record that average, which is going to be total divided by 4. Now, once we calculate the average, we need to reset total back to 0, because when we calculate Jet's average, we don't want to be carrying over Beauty's total average. So we're going to do total equals 0 to reset it. Then we're going to do console.writeLine, and we're going to output the horse just like they did. We're going to use the same format. The horse and horse I dot get name. That way it says the horse Beauty the first time, the horse Jet the second time, has an average. Let's just do the, see here, has an average 78. Yeah, that'll look good. 78, whatever it is. Average. Oh, it's going to be average I. There we go. Let me scroll over so we can see all of this. It's horses I. There we go. Has an average, and then average I, percent chance of jumping over all 4 fences. So that's what they used. There we go. Now the next thing we need to do is output the winner. So we only have 2 horses to work with here. So we're going to check if average 0 is greater than average 1. If it is, then we know that Beauty has won. So we're going to do console.writeLine, and we're going to say, we'll say horse 0. That way we can show them what we're doing. Horse, because if they change the name on us, horses index 0. Get name has the best chance of winning, and then else. And what I'm going to do here is I'm going to copy and paste this, because if Beauty doesn't win, it's going to be Jet winning. He has the best chance of winning because they have the highest chance of success overall. And we do that by looking at the average. So that's going to wrap up this portion of the question. Let's take a look at the next part of this object-oriented programming question. Now they want us to test our program with the following input data for the 4 fences. Now we're not going to enter this once, but we're going to do it twice. Once for Beauty, once for Jet. Once we enter it for Beauty and we enter the 4th fence, once we enter that data, it'll output Beauty's average percentage. Then we'll do it for Jet. After we enter the 4th fence for Jet, it'll output his average or her average, whatever Jet is. Now, we'll be able to see both of those. We're going to compare those numbers and make sure it's outputting the correct horse, either Beauty or Jet, whichever one has the highest percentage chance of winning. So let's swing over to vb.net. Nothing to code out here. Just run our program and make sure it works. Before we run our code, we need to update this chance data type. We need to change it to a decimal. Why do we need to do that? Maybe you were able to notice my mistake that I made earlier, and it was an honest mistake, and mistakes happen, we're all human, but that success method that we wrote earlier, it returns a decimal data type. If I store a decimal data type into an integer, it cuts the decimal off, which is going to affect all my calculations. So when you're looking your code over, just make sure all the data types are correct so you have the right output. So let's go ahead and run this. Now we only need to enter the data once because we have a for loop where we enter the data. Then we have a separate nested for loop that will output all, that will do all the calculations. So we only need to enter it once. Height value of fence 1 is 152, risk value of 5. Fence 2, height of 121 with a risk value of 1. Then we have fence 3, height of 130, risk factor of 3. Then the final fence, a height of 145 with a risk factor of 4. And those are the right numbers that we're looking at. Beauty has an average 48.6% chance of jumping over all 4 fences. Jet has an average of 50.375% chance of jumping over all 4 fences. Now Jet has a higher average than Beauty, and it says Jet has the best chance of winning, which is correct. All right, so that's going to wrap it up for object-oriented programming. Let's take a look at the next question on the paper 4 exam. A linked list stores positive integer data in a 2D array. So this is the abstract data type that they chose for this paper 4 exam, it being a linked list using a 2D array. The first dimension of the array stores the integer data. The second dimension of the array stores the pointer to the next node in the linked list. A linked list node with no data is initialized with the integer -1. So -1 is going to be our null value. These nodes are linked together as an empty list. A pointer of -1 identifies the node as the last node. So not the data -1, but the pointer -1 says, hey, we are the last one. Now this linked list can store 20 nodes. It gives us this. And then the global 2D array, they called it linked list, stores the linked list. Now, the linked list is initialized as an empty list. The data in each node is initialized in -1. Each node's pointer stores the index of the next node. The last node stores the pointer value -1, which indicates it is the last node. So index 0 is going to point to index 1. Index 1 is going to point to 2. 2 to 3, 3 to 4, all the way down, and then index number 19 is going to point to -1 because that's going to be the last index inside the linked list, because when I count 0 to 19, it is 20. Now we have some global variables here. The global variable, first empty, stores the index of the first element in the empty list. This is the first node in the empty linked list when it is initialized, which is index 0. The global variable first node stores the index of the first element in the linked list. There is no data in the linked list when it's initialized, so first node is initialized to -1, that being our null value. So the diagram shows the contents of the initialized array. So we need to set first empty to 0, first node to -1, and then index 0 all the way to 19. We have that data as -1, and then you'll notice the pointer points to the next index of it, and that was described on the previous page. Write program code for the main program to declare and initialize linked list, first node, and first empty. Now remember, linked list, first node, and first empty, those are global variables, so we're going to set it up in there, and then we'll initialize them in sub main. Let's swing over to VB.net and code that out. All right, so we're going to head to where we set up our global variables. We're going to do linked list. Has a max index of 19 rows, which will hold 20 items, and a maximum index of 1 for our columns. We are including index 0, so 0 to 19 rows, 0 to 1 columns, which are 2 columns entirely. Then we have first node as integer. Then we have the first empty. That's an integer as well. All we need to do now is we need to set this up. Our first node is equal to -1 because the list is empty, which means our first empty node, our first available node that we can use to fill, will be set to index 0. So when we add data for the first time, it's going to be added in index 0, and that will become the head of our linked list. The next thing we need to do is we can use a for loop to set all the data to -1 and then initialize the pointers. Now I'm going to do for I equals 0 to 18 because I don't need to do 19. You can go 0 to 19 and have an if statement that checks I to see if I is 19. It's just a lot cleaner to do it without an if statement inside your for loop. So I'll show you how we set that up. It's just 2 lines of code. But let's set these up first. So our linked list, I0. What is inside column 0, that first column? That's our data, which is -1. And then we need to set up that pointer, which is going to be I comma 1. Inside column 1, which is the second column, is our pointer. So index 0 needs to point to 1. Index 1 needs to point to 2. Index 2 needs to point to 3, and so on. So I can't just do I, but I can do I plus 1, which will be the next one. Now, to set up the last index of our list here, all we're going to do is we're going to do linked list, and we're going to type in those numbers manually. So 19,0 is -1, and then linked list, and you want to spell this correctly, 19,1, because that is the end of the list, we make it a -1. And just like that, we're done with the first part of the question. Let's take a look at the next part of the question. The procedure insert data takes 5 positive integers as input from the user and inserts these into the linked list. So we'll just run a for loop, 1 to 5. Each data item is inserted at the front of the linked list. Okay, so what we're going to do is we're going to insert an item, and then what we're going to do is when we insert the next item, it's going to move it to the front of the linked list. This means we are not moving it to the front of the array. Remember, a linked list can start anywhere, and we have that variable first node. So we need to update that so we know where it begins. For example, if I add the data 17 to index 0, and then I add 18, 18 will go in index 1. But my first node variable isn't going to point at index 0. It's going to point at index 1 because we're going to start with 18, and then 18 will point to index 0, which is the next item in the list, which is 17, which is at the end. So it's very, very important. You know that we're moving it to the front of the linked list by adjusting that first node variable. We're not moving it to the front of the array. So make sure you keep that in mind. The table shows the steps to follow depending on the state of the linked list. So if the linked list isn't full, we're going to insert the data in the index pointed to by the first empty, change the pointer to the index pointed to by first node, because if we add an item, we need to know where does our linked list starts. So once we add 5 items, the first node is going to be pointing to the 5th item that we added, and then we need to change the values of first node and first empty. First empty is going to point to the next available index that we can use in our linked list. First node points to where the linked list begins, also known as the head of our linked list. And then if the linked list is full, we're going to end the procedure. Any node that is at the end of the linked list has a pointer of -1, just like index number 19 does. But when we add 5 items, we need to make sure that the item that was inserted first, because that will be the end of our linked list, has a pointer of -1, which means we have reached the end. We don't need to go to any other items. Write program code for insert data. So let's swing over to vb.net. Let's code out this procedure, insert data, take in those 5 items and put them in the correct spot. All right, let's write this sub, insert data, no parameters, no return data type. Now we need a couple of variables. The first one's going to be the item, because the user is going to need to enter 5 items. We don't need an array here because we're going to ask them for the item and then tack it on to the linked list. But we also need to know, we need to set up the next free index, because after we populate index 0, then we need to populate index 1. After we populate index 1, we need to populate index 2, and then so on. Now remember, these items are going to be added to the front of the linked list. So let's do for I equals 1 to 5. We can do that because we're not going to be using any index I here, so we're just going to set it 1 to 5. If first empty equals -1, meaning I have run out of room, there's no more room in my linked list, I need to exit this for loop. I got no business putting in data because there's no room. If there is room, I need to put in data. Now, what I'm going to do here is I'm going to type this code, give you a brief overview, and then we'll take a look at what it's actually doing if we insert 2 items so you have a firm understanding of what is happening. So I need to get items from the user, enter the item, and then item equals console.readline. I think we know what that is doing. We're getting data from the user and putting it inside item. Now, we need to set up our next free. What is our next free index? Well, that's going to be our linked list. Wherever we have an opening, which is held by first empty, column 1 holds the pointer. We're going to get that pointer, and we're going to say that's the next free index. I'm going to walk you through what it looks like in just a minute. Linked list, first empty, which is where we're putting the new item. We're going to put item inside column 0, and then linked list, we need to update that pointer. First empty, well, the pointer is in column 1, first node. Now, we need to set up our first node because our first node right now is -1, which means our linked list is empty. Not anymore. We are putting 0 inside there, and I'll explain that in just a minute. And then our first empty is next free. Okay, that right there will add data. But let's talk about what it's doing. So let's say we're going to add item 10. All right, and then first empty is 0 right now. So we add 10. Linked list, first empty, which means index 0, 1. That holds the pointer. If we look back at our submain, let's just go back to our submain. Let's just go back right here. Our first empty is 0. We set the data up to -1. That's fine. We set index 0 pointer, its pointer, to 1, because what is 0 plus 1? That is 1. So 10 is going inside index 0, but we need to get its pointer to know what the next free index is, because our next free index is no longer 0. We just put 10 in it. So now we need to grab that pointer, which is 1. Our next free index is now, let me make this a comment. Our next free index is now 1, which we'll put inside our first empty because that's where we're going to be placing the next item, which is going to be 5. We'll do that in just a minute. So we take 10, we put it inside the index 0, 0, which is the item. Index 0, 1, what are we doing there? We're taking first node and we're putting that inside 0, 1. Well, what was first node? First node is -1. Why am I putting -1 inside index 0, 1? Because first node is -1, and because 10 is the only item in our list, that signifies the end of the linked list because we haven't added any other item besides 10 yet as we walk through this code. Now, we'll adjust that in a second. Now, first node no longer needs to be -1. My first empty is still 0. So now my first node is now 0 because I'm taking that first empty, which is 0, and I'm putting that into first node, which is 0, not -1. My linked list starts at index 0 because we just put 10 inside index 0. What's my next free index? Well, my next free index is index 1. I put that in the first empty. Now, let's add 5. So we add 5. My first empty is 1 because we just updated it right here. So now, let's add 5. So we enter the data 5. What's my next free pointer? Well, inside first empty, which is 1, inside index 1, column 1, I'm getting that pointer. What was the pointer index 1 pointing to? It was pointing to index 2. So now my next free pointer is index 2. What am I putting inside index 1, column 0? I'm putting that item, which is 5. My first node is 0. So what am I putting inside linked list, index 1, column 1? The first node. I've moved 5 to the beginning of my linked list. So when I get to index 5 and I look at 5, 1, when I look at its pointer, it's going to be pointing to first node. And that first node is index 0. So it's going to print 5, point to index 0. What is the item in index 0? That's going to be 10. Now I'm going to take my first empty, which is 1, and I'm going to make that my first node. So now my first node is starting at index 1, but I've already updated the pointer. So when we print index 1, it'll point to 0. And that's what we did here on this line that updates the pointer. What's my next free index? Well, my next free index is 2. Now my first empty is 2. So when I add another item, it can go into the next index and update those pointers all over again. Let's take a look at the next part of the question. The procedure output linked list outputs the data in the linked list in order by following the pointers from first node. Write program code for output linked list. Then we're going to min the main program's submain to call insert data, which we just wrote, and then output linked list. So that way after we put in the data, we output the linked list. They want us to do 1, 5, 1, 2, 3, 8. Now remember, every time we add data, it should be moving to the front of the linked list. So let's swing over to vb.net. Let's write output linked list. Let's update submain to call insert data, output linked list, and test the data they give us. All right, and all we're going to do is we're going to write that sub output data. And all we need to do is have a pointer. So I'm going to do cur pointer for current pointer as integer. And all I need to do is make sure that our pointer is never -1, because once it's -1, we've reached the end of the linked list. So we're not going to be printing out all 19 indices. We're going to, or all 20, 0 to 19. As soon as we get a pointer of -1, we know we've reached the end of the linked list. So where am I starting? Well, I'm starting at my first node, whatever it may be. So if I added 2 items like 10 and 5, just like we talked about, my first node is going to be index 1. So we just talked about that. Now, while my current pointer is not -1, so if it's not equal to -1, then I can go ahead and I can start outputting that data. What am I outputting? Well, I'm outputting my linked list, whatever pointer I'm at, and I'm outputting the data that is in column 0. Then what I need to do is I need to update my current pointer. What is the next item it's pointing to? Well, that's inside my linked list, wherever I am currently inside column 1. That is where it is. Int while, and just like that, we're done. If you spell while correctly, you're done. There we go. That will do it right there. While doesn't have a then statement. Don't know what I was doing there, but this right here, this loop, as long as we're not at -1, as long as the pointer isn't at -1, we're going to output the data. Once it's -1, we're just going to skip right out or break outside this loop and go ahead and move on to the next line in submain. That's it right there. Not too complicated at all. So now we're going to go to submain. We'll make sure we initialize everything. We're going to go to insert data. Then we're going to output the, is it output data? I think it should be output linked list. Yeah, they called it output linked list. So we need to call it output linked list. There we go. Go back to submain, because we are outputting data, just outputting the data inside our linked list. Then we're going to save. We're going to run our program and make sure we get the expected output. So we run our program. We look for the data they give us, which is 5, 1, 2, 3, 8. All right. Let's check this out. So 5, 1, 2, 3. Now, when I hit 8, it should output 8, 3, 2, 1, 5. It should be going backwards because every time I add an item, it should move to the front of the linked list. So our first node is going to be 8. And you can see it's 8, 3, 2, 1, 5. It prints exactly like it's supposed to. Let's take a look at the next part of the question. The procedure remove data removes a node from the linked list. The procedure takes the data item to be removed from the linked list as a parameter. The procedure checks each node in the linked list, starting with the first node until it finds the node that needs to be removed. This node is added to the empty list. Pointers are changed as appropriate. The procedure only removes the first occurrence of the parameter. Assume that the data item being removed is inside the linked list. So we don't have to check and traverse the list to make sure it's actually there. It says assume the data item being removed will be inside the linked list. Write program code for remove data. Let's swing over to vb.net and let's write the remove data code. All right, this next part's going to be done in a section. So we have sub remove data by val item as integer, because it does accept a parameter. We'll type in our in sub. Don't want to have red lines here. Be a little harder to debug our code. All right, we're going to need some variables. So we're going to need cur pointer, so we know where we're at. and that is in case we need to traverse the list. We have a previous node, that's going to be an integer. We're going to have found as Boolean, that's going to be for our loop. We're also going to have not end as Boolean, that's also part of our second loop, or our first loop, or the only loop that we have. And then what we need is we need next node as an integer. All right, let's break this down into 3 parts. The first part we need to do is we need to see, is the item we are removing the first item? That's what we're checking first. So if our first node isn't -1 and our linked list first node 0, if that's equal to our item, we have found the very first item we need to remove. So we actually need to remove it. So that means our next node is equal to linked list first node 1. I'm updating that next node pointer. Then I need to clear the data. I need to remove that data. So I do linked list, my first node, wherever I'm starting, because if there's only one item, it is my first node. So I'm clearing that first column, making it -1. Then my linked list, first node, I need to update its pointer. What am I updating the pointer to, or what am I updating its pointer to? Back to first empty. That is what I'm adding. So I'm adding it back to the free list. I'm updating my first empty code to first node, and then my first node, and you want to spell first correctly. Now my first node is whatever the next node was. What is that? What has that done? It has updated the head of our linked list. Now, once we do that, we exit sub. We don't need to stick around and check the rest of it because it was the first item. It's the only item. We don't need to do any other part of this next section of code that we're about to write. Now, for this next section of code, we need to traverse through the linked list to find the item because it's not the first item. So we got to go through and we got to find it. So our current pointer, we're going to do that with first node because we're going to start at our first node. Now our previous node before we enter this is equal to -1. And then we haven't found it. So we set found equal to false. We're not at the end of it. So not end is true. So we're going to do while found equals false. And we're not at the end. So while not end equals true. We're going to make sure our current pointer isn't equal to -1. And if it's not equal to -1, then we need to see if where we're currently at matches the item. So we do if linked list, current pointer where we currently are, we're checking the data, which is in column 0. If that equals item, then we found it. So found equals true. There we go, scroll down a little bit. All right, so again, we're starting at whatever the first node is. We're checking to see, we're checking the data to see if the data, which is in column 0, is equal to the item. If it is, we have found it. Now, if it's not there, then what we're going to do is we're going to do our previous node. We're going to update that with its current pointer because the previous node we were at, we're going to take wherever we were because we haven't found it yet. We're going to put that into previous node, and then we're going to update our current pointer. Where's our current pointer? Well, we're going to look at wherever we currently are, and we're going to grab that pointer. Now, once we have that, we're going to go right outside this end if. And then if that's not true, then we know that not end equals false because we are at the end. So if linked list, if current pointer equals -1, if it does equal -1, we are at the end. So not end equals false because we are now at the end. If it matches the item, then we found it. If it doesn't match the item, we need to look for the next item. We're going to take current pointer. We're going to put that in the previous node because we just checked it. We need to keep track of that previous node. Then we need to update current pointer to the next item. And remember, wherever we're at its pointer points to the next item in the list. That is the end of part 2. Now let's do part 3 of this code and wrap up removing a node from the linked list. There's a lot going on in the remove data code. That's why I've broken it into 3 sections. That way you can spend time looking at each part, because if I just throw all this code on here, it's a lot to try to figure out what's going on. By breaking it into sections, it's a lot easier to understand. So we found the item. We found the item. We've traversed through. We found the item. So found equals true. Then what we need to do is we need to bypass that node. So we're going to do linked list. That's why we had previous node. We need to update its pointer. What are we updating the pointer to? Well, that's going to be our linked list, wherever we're currently at. Cur pointer. We need to grab that pointer, and that's in column 1. Then what we need to do is we need to clear that data, just like we did when we started this. We said if it's in the first item, we need to clear the data. Here, we're not at the first item, but we still need to clear the data, setting it to -1. Then we need to update its pointer. So linked list, current pointer 1. What are we setting inside that? That's going to be first empty. That way we know it's pointing to the next available index. We're adding it to the list of free spots. Then we need to update first empty to cur pointer, and that will update the next free slot. So we take the free slot, put it in there, and then we update the actual first empty for the next available slot. And just like that, we have done all 3 parts. Let's take a look at the next part of the question. All right, I'm in the main program, submain. We're going to call remove data with the parameter 5, output the word after, call output linked list. Then they want us to test our program with both sets of given test data, 5, 6, 8, 9, 5, 10, 7, 8, 5, 6. And remember, it should output it backwards. Now it's very interesting because we have 5 both at the beginning and at the end, and earlier it said it removes the first instance, so it should remove that first 5 that we have there. Then 10, 7, 8, 5, 6, there's only one 5, it should remove that one. So that's why they've given us 2 sets of test data to make sure our code actually works by removing the first instance of 5 and then only the 5 in test 2. So let's swing over to vb.net. Let's add some code to submain so we can call our remove data, make sure it all works. All right, so the first thing I'm going to do is I'm going to comment out this first output linked list, because what we're going to do is we're going to be removing it. So what we're going to do is we're going to insert the data. Actually, we're going to output it. We are going to output it. Then we're going to do console.writeLine after removing the, or it just said after. So after removing the data, we're going to output a linked list again. We actually need to remove the data. So we'll output the linked list. There we go. Okay, remove data. And then they want us to remove 5 and run it twice. Okay, so we're going to insert the data. We output it, remove data 5. Okay, yep, that's everything we need. All right, let's go ahead and let's run this. Now, our first set of test data has 2 5s. It should only remove the first item of the first time it encounters the 5. So 5, 6, 8, 9, 5. And that should output 9865. So 59865 after we remove the data, 9865. Perfect. That works as intended. Now it should also work with the singular. If it works with 2 5s, it should definitely work with 1 5. So the second set of test data is 10, 7, 8, 5, 6. And this should output 6, 8, 7, 10. So 6, 5, 8, 7, 10 after 6, 8, 7, 10. So it works perfectly. It does exactly as it's needed. Now don't go anywhere. We're not done with this paper 4 exam. I want to talk about some things that you need to know for paper 4. Then we're going to take a look at the grade threshold, which may alleviate some stress that you have. So let's swing back over to the PowerPoint and let's talk about a little bit about this exam, what you can learn from it, as well as the grade thresholds. So before we continue on, I want to say thanks a lot for watching. These videos, I don't mind doing them, but they do take a long time to put together. Even though the video, you see the duration of it, which is pretty long, it takes about 3 times as long to put it all together. I got to write the code, I got to test it. Then more importantly, I want to be able to explain it to you, because it's not about knowing code, it's about understanding code. So if you found this video helpful, please just take a moment, give it a thumbs up, leave a comment below. I love hearing from you guys, but let's go ahead and get ready to wrap this up. So what should you focus on from this exam? Well, reading from a file is the first thing. Now, this has been on every paper 4 exam for Computer Science 9618. You need to know how to open it. You need to know how to read the data from it, and don't forget to close it. You got to remember to close it. Make sure to put it in a try-catch statement, as they will expect you to put it inside a try-catch statement. One more piece of advice about that. Make sure if you open the text file, because you want to preview the contents, like you actually double-click on the TXT file, that you close it. Your program's not going to be able to access it if you leave it open. Also, you need to focus on sorts. Now, this test used a bubble sort. Don't forget, there's also an insertion sort that you need to know, so make sure you review that as well. And don't confuse sorts with searches. There were no searches on this exam. There was no linear search, there was no binary search, and because there was no binary search, we know there was also no recursive binary search. Make sure you review those searches. For object-oriented programming, you need to know how to declare a class. Make sure you make all the attributes private. Know how to use your constructor. If it accepts parameters, how do you take those parameters, set it to the attributes? Know how to write your get methods, and know how to apply other methods, including those set methods, in case your constructor doesn't set values. Now, sometimes you create objects, just 1 or 2 of them. Other times, you're going to need to create an array of objects like we did today. Linked list, this is one of the abstract data types. Now, the others that you need to know binary trees, you need to know queues, and you need to know stacks. Be familiar with each one, as one of these will appear on the exam for sure. So they could ask you about any of those. Be familiar with them, and let's move on and talk about the grade thresholds. But you can do all of this. Believe in yourself, put in the time, and you will succeed. If you wait until the night before, it's not going to go too well. But you're putting in the time, you're going to be able to succeed. Here are the grade thresholds. So we did variant 1 today. This is from the November 2024 examination, so literally just a couple months ago. And component 4.1, for an A, you need a 52 out of 75. For a B, you need 41. A C, a 32, a D, 24. But just to pass this exam, out of a total of 75 points, you need 16 points. So you can see for your A level, it's going to be paper 3 and paper 4. So if you're doing component 1, you're going to need 39. Am I adding that right? 23 plus 16. Yeah, you're going to need 39 out of 150 to get your A level credit. You are definitely more than capable of doing so. 39 out of 150. You can definitely get a lot higher than that. You'll be in the A-B range for sure. You put in the time, you'll definitely be in the A range, but you can do this. Hope you guys found this video helpful. We'll see you guys in the next Paper 4 review video.